Welcome to another video for organic chemistry. In this video I'm going to be discussing carbocations. To demonstrate this principle I'm going to start off with propylene combining with hydrochloric acid in a reaction. And as you know, if something is an acid, that means it's going to dissociate a hydrogen proton, okay, a hydrogen atom or cation. Propylene is an electron-rich molecule demonstrated by the double bond that you see there in between my second and third, or my first and second carbon bond. Okay, and that is where the electrophile hydrogen is going to get its electrons from. So that pi bond, so you have a sigma and a pi bond and a double bond, that pi bond will break and those electrons will then be used to form a bond with hydrogen. Okay, my electrophile. So hydrogen has an option of combining with my first carbon or my second carbon. Okay, that will create two different species that we're going to discuss. The first one, let's say that hydrogen combined with my third carbon, creating an H3. If it combined with my third carbon, that H3, then that would leave an empty orbital with my second carbon, as you can see there. Okay, that empty orbital would create a positive charge called a carbocation. This is where I get that term. That's an empty orbital. It's very unstable. It doesn't like to stay that way. These molecules are typically intermediate species. So they are an in-between step between my beginning reactant and my final product. Okay, so what would happen if that hydrogen combined with my middle carbon? Well, if it combined with my middle carbon, then that would satisfy all the bonds necessary for that particular carbon, leaving an empty orbital on my third carbon, as you can see there. That would create what's called a 1-degree carbocation. So as you can see here, I have two different species of propylene here. I have a 1-degree carbocation and a 2nd-degree carbocation. Notice where the plus charge is in each one of these carbocations. In the middle one, you have the plus charge in the middle carbon, where the empty orbital is. And on the third species, you have the empty orbital on the third carbon, and that's where the plus charge is. So that is a 1-degree carbocation, meaning it's only bonded to one other carbon species. Okay, so that's the CH2 you see in the middle. And if you look at the one in the middle here, you'll see that this carbon has two different carbon species, two methyl groups that it's attached to. So the question is here, so here I have two different species, two molecules that can form, two potential options that can occur. Okay, so the question is which carbocation is most likely to form? Does chemistry have a particular preference to which one of these it wants to create? And the answer is yes, and that's what we're going to discuss. So the 2nd-degree carbocation is more stable, more so than the 1st degree. This is less stable. In general, 3rd-degree carbocations have a greater stability than 2nd-degree, and the least is a 1-degree carbocation. The reasons for this greater stability is, number one, something called inductive effect, and also hyperconjugation. Now, I do have a separate video where I discuss what exactly is inductive effect and hyperconjugation. So if you don't know what those terms are, please go back and watch that particular video. I'll put a link right here so you'll know where to go. Okay? So, as I mentioned before, your 2nd-degree carbocation is more stable than your 1st-degree carbocation. So that is where you'll notice that the chlorine decides to make a bond with that middle carbon. Okay? So that empty orbital gets filled up. Those electrons get filled with the extra electrons that chlorine has. So the chlorine has plenty of electrons to make a bond with something else and does so with that carbon in the middle. Okay, so that does it for this video for carbocations. Thank you for watching and good luck in your studying.